Now I am going to discuss more about symmetry elements. That means the important relations between the symmetry elements. For example, the rotational axis of symmetry Cn. Cn power n will give E, where n is even or odd, where this n is order of rotational axis and this n is number of rotational axis. For example, if C2 is twofold rotational axis, right? If it is performed by 2 times, it will give E. If it is C3 axis, if it performed by 3 times, it will give identical configurations. Like that, C4 will give E, C5 will give E. That means where n is even or odd, it will give the identical configuration when Cn power n. For example, if we take the Bx3 model. In Bx3 model, the angle of rotation is 120. So, resultant rotational axis is C3, right? If we performed C3 at one time, we will get the equivalent configuration like this. Okay. Again, we putting the rotational axis at second time. C3 at second time. It will give the configuration like this. That means 1 and 2 and 3 are equivalent configuration to each other. But when we performed again third time the C3 rotational axis, the resultant configuration is this one. That means the resultant configuration is identical to the original one. So C3 power 3 has resulted. Next relation is sigma power n. Sigma power n will give E when n is even. Sigma power n will give sigma when n is odd. For example, if we take Bx3, when we doing the reflection operation at one time, it is giving the equivalent configuration, that is reflected operation, right? And at second time, that is n is even, it is giving the identical configuration to the original one. Relation is improper axis of symmetry. I power n will give E, where n is even, I power n will give I, where n is odd. For example, if we take 1,2-trans-dichloroethylene, so when we're doing the inversion operation, it is giving the equivalent configuration, inverted configuration, right? Next, by doing the second operation, that is I at second time, that is n is even, it is giving the identical configuration to the original one.